Good morning guys and welcome to my channel Mind Your Math. Today we are going to do a basic quiz on polynomials. Basically it is a ABC series in which we are doing a few questions to check whether your understanding of the polynomials chapter is solid or not. Now all of these questions are taken from various websites and all of them are based on the CBSE syllabus. And a few questions have been taken directly from the NCERT website. So you know that you do need to do these questions because just in case they might even come for your board exam. Now let us start with the first one. Before that, let me tell you, you know where to drop a comment or mail me if you have a doubt regarding any of these questions. Now let us start with the first question. If fx and gx are polynomials of degree 5, will fx plus gs be a polynomial of degree 5 is a question. So we need to say whether that particular statement is true or false. Now what do you mean by degree 5? There is a term in the polynomial whose highest degree is 5. So fx is a polynomial of degree 5, even gx is a polynomial of degree 5. So fx can be something like 3x raised to 5 plus 4x raised to 4 minus 3x cube plus 9. It may have a quadratic term, it may not have a quadratic term, it doesn't matter. We are bothered only about the term which has a degree 5. Now gx might be something like 6x raised to 5 plus 9 or plus 19, anything for that matter. Now in mathematics, in order to prove a particular statement is wrong, we need only one example. Somebody says a statement, if you want to prove it is wrong, you don't have to make a general proof. You just need to show one example. But in order to show if a statement is true, you cannot show it with examples. You need a general proof that is applicable to every single number or every single term as far as your math is concerned. Okay. In this case, I just need to check whether adding both of them will give me a polynomial that does not have a degree 5. Okay. Suppose my fx is this polynomial and my gx is a polynomial of, let it be this. What will happen when I am adding it? When I am adding it, my x raised to 5 term will get cancelled because it is 3x raised to 5 and minus 3x raised to 5. It will have definitely the remaining terms, but the degree of the resulting polynomial will not be equal to 5. So when fx and gx are added and both of them have a degree 5, the resulting polynomial, which is given by fx plus gx, may or may not have a degree 5 depending upon the coefficient over here. Clear? Can you give me one more example where the polynomial will not be of a degree 5? Let fx be x raised to 5, a simplest one, gx be minus x raised to 5. When I am adding both of them, what do I get? I get a 0. So this particular statement that fx plus gx also will have a degree 5 is completely false. X square plus 99, x plus 127, they are asking about the nature of the zeros. Both are positive, both are negative, both are equal, etc. etc. Now, one way of doing it is to actually find out the zeros and then, check your options. Now, sum is 99 and the product is 127. If you are able to find out the zeros, well and good. If not, I will tell you an easy way to do this. If all the terms of a polynomial are positive, the roots are never positive, roots or zeros are always negative. Can you tell me why? Take a very easy polynomial. My factors are this. The factors has to have a plus sign over here because all the terms are positive. When the factors have a plus sign, what will happen to the zeros? The zeros will definitely have a minus sign. I am just taking an example and telling you this is true for every single polynomial. You don't have to go into the proof of that part. You can just use your basic common sense to understand that if all the terms are positive, the factors will always have a positive sign between them with no negative sign. Therefore, the zeros will always be negative. In this particular case, both the zeros are, because it is a quadratic, two zeros are there, both the zeros will be negative. Okay. If fx is equal to 0, is it a polynomial? If it is a polynomial, they are asking for the degree of the polynomial. You know that constants or basically numbers are treated as polynomials. So a 2 or a 20 or a minus 3 by 2, they are all polynomials, being that the degree of that polynomial is equal to a 0. Okay, suppose you have a polynomial given by 5. You know that there is an x term with a power of 0 over here. So I can say that the degree of this particular polynomial is a 0. Now we have also learned that when that number is actually 0 or the polynomial is given as a 0, it is a special case of constant polynomial. These polynomials are called constant polynomials. So 0 is a special case of constant polynomial called as the 0 polynomial. And the degree of a 0 polynomial is not defined. So this all come under the basics of polynomials or the definition of various type of polynomials, which I have already gone through while I was explaining polynomials in the class. So the number 0 is definitely a polynomial. It is called as a 0 polynomial, which comes under constant polynomials, but the degree of a 0 polynomial is not defined. Is 1 by x a polynomial? Now, you know, by the basic definition of polynomials, variables and constants which are joined together by the mathematical operators are basically called as polynomials, and the powers of the terms should be non-negative integers is a major condition. So you cannot have terms like x raised to 1 by 2, root of x, x raised to minus 3 or x raised to minus 1, which is actually 1 by x in an algebraic expression, and we cannot call it as a polynomial. Okay, so x, the powers of x should be positive integers. It cannot be anything else. So if you find any other term, you can directly say it is not a polynomial. Therefore, 1 by x, which actually is x raised to minus 1, is not a polynomial. Similarly, 1 by x square or root of x plus 1, 1 by x plus 1, all these are not polynomials. In the question, a polynomial is represented by a graph. We need to figure out which could be the polynomial that is represented by the graph. 4 options are given to us. Now, how do we figure out the polynomial from a given graph? Now, when you look at the polynomial, you can identify, or when you look at the graph, you can identify what kind of a polynomial it is. This is the graph of a quadratic polynomial because it is curvy and it has got one turn. So it is a quadratic polynomial. So in your textbook, if you have seen, this is one of the first images that is given to you, the U opening upwards. Okay, so you know this is a quadratic polynomial. Now, for any graph, in order to find the zeros or the roots of the polynomial, how do we find it? It is a point where the graph crosses the x-axis. So from this particular graph, can you find out the roots? It is x is equal to 5 and x is equal to minus 6 are the roots of this particular quadratic polynomial. Now, when x is equal to 5, you know that x minus 5 is a factor, and when x is equal to 6, x plus 6 is a factor. When x is equal to minus 6, x plus 6 is a factor. Fine. A quadratic polynomial is obtained by multiplying two linear factors. So, we already got the factors. Now, let us multiply and see what we are getting as a polynomial. This is our right answer. So, if a graph is given to you and you need to find out what could be the polynomial, see, the problem is that this is one option for a polynomial. You know, there can be multiple polynomials with the same roots. So, this could be the equation, or this could be the polynomial representing this graph. Okay. Now, let me do a recap. Identify the roots, equate x to those roots, then identify the factors, multiply them and get this. How many turning points does the graph of a quadratic polynomial have? Now, what do you mean by turning points? If you observe the graph of a quadratic or a cubic polynomial, you can see that it's a u for a quadratic. Okay, it could be in any shape, but because it's a u, you can see that the graph starts from here, comes over here, and then turns and goes upwards. So this part is called as a turning point. The graph was going downwards, suddenly it decided to stop over here and move upwards. That is called as a turning point. So how many turning points will the graph of a quadratic polynomial have? One turning point. Okay. We need to write a polynomial of degree 3 whose roots are given by, or root zeros are given by -1, 2 and 4. Very easy, because the zeros are given by -1, 2 and 4. You can easily write the factors x plus 1, x minus 2 and x minus 4. Since we already got the factors of the polynomial, multiplying them together will give us the polynomial. So our required polynomial is obtained by x plus 1 into x minus 2 into x minus 4. So let us see what we are getting. Into x minus 4. So when we multiply x cube plus 8. Now let us rearrange the term and put it in the proper form. So you will get x cube minus 5x square plus 2x plus 8. Suppose the question is, write two cubic polynomials whose roots are given of degree 3, whose roots are given by -1, 2, 4. How will you do it? You know this is one answer. What is my second answer? You know about a coefficient k which we use to write the equation of the polynomial. Suppose you have a polynomial fx whose roots are given by this. K into fx also will have the same roots where k is any number. Correct? Now, if this is one polynomial, if I am multiplying the whole polynomial with a 10, what will we get? 10x cube minus 50x square plus 20x plus 80. Even this particular polynomial will have the same roots. What is the reason? When I am taking 10 out, I am getting back my original polynomial, right? The roots of this original polynomial are -1, 2, 4. So, if you want two polynomials, just take the original one and then multiply it with a number. See, all this concept has already been explained many times, but still I am repeating it. You can multiply it with any constant in order to get another polynomial. Like in the same way, you can get any number of polynomials having the same roots. We just say they are a family of polynomials. Family of polynomials means the polynomials having the same roots but different value of the constant over here. Okay. The number of polynomials having zeros as -2 and 5. I just explained it now. Multiple polynomials can have the same zeros and we group them together and say that they belong to the same family of polynomials. So likewise, the polynomials having zeros -2 and 5 is definitely more than 3. A quadratic polynomial of the form x square plus ax plus b is given to you, and it is also said that one root is a negative of the other and 4 options are given to us. We need to tick which is the correct option. Now, one root is a negative of the other means if the roots are alpha and beta, it just became alpha and minus alpha. Okay. Let us take the sum of the roots. Alpha plus minus alpha is equal to minus b by a. Alpha into minus alpha is equal to c by a. Okay. Now, alpha plus minus alpha will give me 0, which means that the value of a just became 0. My linear term disappeared. Now, the second option, minus alpha square is equal to b. Or I can say alpha square is minus b. Now, what happens? Alpha or the root of the polynomial is the root of -b, which is not a number in real number system. Correct? So, in order to avoid this problem, my b value or the constant term has to be negative. If the b value is negative, minus of minus will become a plus over here, just then giving me a proper value for alpha. So what is my option? My linear term is 0 and my constant term has to be negative.